So problem 3 is in a separate video because my Word document crashed. So that's fine. So it'll be a short one, okay? So here's problem 3. You have been given 2 half reactions and their reduction potentials. And it's important to note that they are reduction potentials, and this is probably what will be given to you on the AP exam. Just the reduction half reactions and their reduction potentials. So if you look at the 2 reduction potentials, one is very much more negative than the other one. We have aluminum with a reduction potential of 1.66, that's negative, and the negative number is always the one that undergoes oxidation, and the more positive number will undergo reduction. Okay, so that also means that if aluminum is undergoing oxidation, this reaction is going to go in the direction where aluminum is being oxidized. That means when we're doing the calculation, we have to flip the sign, and the fact that this is also the anode, okay? And the reduction will happen at the cathode. So now we're ready to answer the questions. So the anode reaction is going to be, don't just write the Al plus 3 electrons. You'll see the equilibrium arrows here showing that it can go in either direction. But if you make a galvanic cell with aluminum and bromine, you should know that it's always just going to go in the direction of oxidation. So aluminum solid will go forward towards aluminum 3 plus 3 electrons. So it's the reverse of the reaction that has been given, and I'm deciding to just write the forward arrow, okay? And then the cathode reaction is going to be exactly as it is shown, just Br2 plus 2 electrons going to 2 ions of bromide. Okay, so that is what's happening in the cathode, where bromine is being reduced to bromide. Now, the overall reaction, you have to do a bit of work for it, right? Because you have to balance the charges and whatnot and the number of electrons. Bromide is only using 2 and aluminum is using 3, which means we have to do a bit of work here. So Al is going to Al plus 3 electrons, and Br2 plus 2 electrons is going to 2Br minus. We have to find a common number for 3 and 2. That's going to be 6, right? So multiply this by 2, multiply this by 3, and then we will get 2Al is going to 2Al plus 3 plus 6 electrons, and we will get 3Br2 plus 6 electrons. Purple. 3 times 2 is 6 electrons. Is going to 2 times 3, 6 bromines, or bromides. 6Br minus. Okay, so let's get our overall equation here. 6 electrons on the product side, 6 electrons on the reactant side. They will cancel out. So on the reactant side, we have 2 aluminum plus 3Br2 is going to 2 aluminum plus 3 plus 6 bromide minus 1. So charges are balanced, numbers are balanced. On the reaction side, there is 0 charge. On the product side, there is 2 times plus 3 plus 6, and 6 times the negative 1, negative 6, plus 6, negative 6 balance out. And that is our equation, okay? That is our overall equation. So I got 2Al, 3Br2. Over here, I have to write 2 aluminum plus 3 Br2 is going to 2 Al with the plus 3 charge plus 6 Br minus. So that'll be solid, this will be liquid, this will be aqueous, and this will be aqueous. All right, it's usually liquid. Bromine is liquid and bromide is aqueous. This is aqueous. All right, then cell notation is just going to be aluminum solid, oxidation on the left always, aluminum solid, vertical line becomes aluminum plus 3. Double vertical lines to show salt bridge. And then, don't need the 3 there, just bromine. Sometimes it works, sometimes it doesn't, the eraser. Br2 liquid, vertical line is becoming Br minus aqueous. All right, so oxidation and reduction, okay? Then cell potential, you have been given the numbers already. So remember the equation is E cell is equal to the half cell potential of the oxidation reaction plus the half cell potential of the reduction reaction. Remember to flip the sign of the oxidation reaction to be positive because it's going in the reverse direction. So E cell is therefore equal to 1.66 volts plus 1.07 volts, which will be equal to 2.73 volts. Okay, I think that's correct. Let me see. 1.66 plus 1.07. Yeah, 2.73 is correct. Okay, so you have a nice positive value. This is thermodynamically favorable. So the last question F, the calculation for delta G, that is coming in the future, okay? To be continued here. You can predict the sign of delta G. Delta G will be negative because E cell is positive. If it's thermodynamically favorable, delta G has to have a negative sign. But there is an equation that connects E cell and delta G, and that is coming up in your future. All right. Bye, peoples.